All right, good morning, everybody. We're looking at Unit 12, Lesson 4, more of our circles and how lines intersect inside and outside the circles and what that does to the angles, arcs, segments, all little pieces of everything as it intersects. Okay, so the first thing is if we have two lines that intersect inside the circle, okay? If you look at the picture, you can see they're dotted where it goes outside. So that's to show that it doesn't really matter if they all intersect. They intersect inside the circle, if the lines continue outside the circle or not. So whether they're lines, segments, rays, chords, whatever, okay, whether they continue past the circle or not, okay. So if they intersect inside the circle, okay, if they intersect inside the circle, the angle is half the sum of the two arcs. So basically what you're looking at is if you have those two that intersect inside, it's basically the average of the arcs, okay? So quick example, if this was 40, this was 50, angle 1 would be half of that sum, so 1/2 of 90, so this guy would be 45 degrees, right? And about that. Easy stuff. Okay. If they intersect outside the circle, it's half the difference. So you would subtract them, divide by 2. So 80, 30, let's say, right? You would subtract those two, 80 minus 30 would be 50, half of that. So angle 1 here would be 25 degrees. Okay, no big deal. And that doesn't matter whether the line, segments, rays, whatever, both pass through the circle, or one or both could be tangent to the circle. It works the same way. Subtract, divide by 2. Okay, and that's if they intersect outside the circle. Okay, a couple quick terms, or one quick term, a secant. A secant is a line that intersects a circle at 2 points. So basically, we put point C and D right there. Segment CD is just a chord. Okay. Line AB is what we call a secant. Right, so again, chord, right, would be CD, which is the segment. A secant is the entire line where it goes all the way through. Okay. So a secant contains a chord. Right. What is the value of the variable here? Our first real example. Right. So we have these two that intersect inside the circle. Right. Since they intersect inside the circle, it's 1/2 the sum. Right. So we're going to have 1/2 90 plus 46. So that's 1/2 of 136. So 68 would be X. Okay, again, since they're inside, half the sum. Right? These intersect outside. Right? So it's 1/2 the difference. Okay, so it'd be 1/2 95 minus 20, so 1/2 of 75. So 37.5 would be Z. Right? Then this example, this problem comes up a lot in the homework and quizzes and stuff. It looks complicated because it's a word problem and there's a lot of big numbers, but for the most part, it's just two lines intersecting outside the circle that are both tangent. Okay. So Earth's equator is a viewing angle of Earth formed by two tangents. The viewing angle is about 17.5 degrees. What is the measure of the arc of Earth as viewed from the satellite? Okay, so it wants to know this piece. Right there, right? What part of Earth can you view from the satellite? Okay, well, first, a full circle is 360, right? So this other part would be 360 minus x, right? Because we know the part we can see is x, the rest of it's going to be 360 minus x, okay? So since it intersects outside, that's difference. So 17.5 is the angle formed by the two tangents. So that's going to equal 1/2 the difference of 360 minus x, right? Because we have 1 for the 360 minus x for arc AEB, 1 for the x that's arc AB, its difference. That's why they're all minuses. So we're going to 1/2 360 minus 2x is equal to 17.5. Okay, I would multiply everything by 2 to get rid of the fraction. Let's move this over here. Okay, so multiply everything times 2, gets rid of that fraction. Actually gets rid of the fraction and gets rid of your decimal over there. So 17.5 times 2 would be 35 is going to equal 360 minus 2x, right? So I would add the 2x to each side, minus the 35 from each side. So 2x is going to equal 360 minus 35. So 325 divided by 2. 325 divided by 2. So x is 162.5. So that's the part of Earth you can see from the satellite. And if you really wanted to figure out what the other part of it is, you would just plug it in and subtract from 360. And I'll tell you what the rest of the Earth is that you can't see. Okay. But you can see 162.5 degrees of Earth from the satellite. Okay, yeah, it's degrees, it's arc measure. Asking for the measure of the arc. In order to find that actual length, you'd have to know the radius of Earth and stuff like that. All right, segment properties. So not only does it do stuff with the angles when it intersects inside and outside the circle, it also does stuff to the segments. Okay, so when it intersects inside the circle, it takes those two segments, and then actually the product of the pieces is equal. So let's see, maybe 6 and 3, right, which is 18, and 9 and 2, which is also 18. Right, so the product of the two is the same. Right, if it intersects outside the circle, your product is the piece that's outside and then the sum of both parts. If you have a tangent, then it's just that part squared. All right, so it's t squared since it's a tangent. All right, so find the value of the variable inside the circle. So here we're looking for y. Since they intersect outside, right, there's my intersection outside the circle. I'm going to have 6 times 6 plus 8 is going to equal 7 times 7 plus y. Okay. Don't get too worried about how some of this works. It's not as bad as it seems. Don't try to start solving things. Simplify all of it first, right? So order of operations, 6 times 14 equals, we'll go ahead and leave this alone for right now. 7 times 7 plus y. 6 times 14 is 84. And here's why I said to go ahead and leave that right side alone, right? Can we divide 84 by 7? Yeah. So let's do that because that's going to make things easier in the long run. 12 equals 7 plus y. Right? If you couldn't divide 84 by 7, those weren't divisible, you would want to go ahead and distribute the right side and then start working through it that way. Okay, but here you can, so we wind up that y is 5. Okay. All right, find the value of the variable inside or in the circle. Here they intersect. Outside, z is actually the value of the tangent segment there. Since it's a tangent segment, we're squaring it. So it's z squared outside times the sum. So z squared is going to equal 8 times 24. So z squared is going to equal 192. So z would be the square root of that. So it'd be approximately 13.9, unless it wants it in simplest radical form, in which case you'd have to see, right, 192 has what perfect squares in it. Okay, well, I multiplied 8 times 24 to get there. So I know I'm going to have a 4 in there. Right, so if you actually just kind of take this one and go ahead and break this apart, right, 8 was 4 times 2, 24 is 6 times 4. So I know I'm probably going to have a 16 in here. So 192 divided by 16 is 12. Right, 16 and 12 would give me 4 square root of 12. I know 12 still has a square in there of 4. So 4 square root of 4 square root of 3. Square root of 4 is 2. So 8 square root of 3 would be the same thing as that in simplest radical form. Right. Depends on what math lab question asks you for. This one doesn't say, it just says to find it. All right, find the diameter of circle O. So whether that's a diameter or not, we still know this intersects inside the circle. So we still know we're going to have the product of all the pieces are going to equal each other. All right, so we'll go ahead and call this part X. So 9 times X is going to equal 16 times whatever this piece is. All right, so if you remember back to the last thing we did, if a diameter is perpendicular to a chord, it bisects the chord. So this piece is 16 as well. So we get 9 times X equals 16 times 16, or just 9X equals 16 squared, which is 256. So we divide that by 9. So we get X is roughly 28.4. Okay, not your actual answer yet, because what's the diameter? So we have to add 9 back to that. So the diameter would actually be 37.4 repeating. Okay. I believe that's the last example. All right, so if you look through on Classroom, today obviously is 12.5. I'm sorry, 12.4. Wednesday will be the notes for 12.5. We're looking at our Unit 12 test. I think I put on there Wednesday, which gives us a lot of time to actually go over things, answer questions, although that has been somewhat of a disappointment. So Tuesday and Thursday, basically work days. Friday, Monday, and Tuesday would then be question days. Again, like I said, that's been somewhat of a disappointment. Last week, we had 2 days that we were on for Q&A, live Q&A, and I had a grand total of like 2 people that showed up. So ask questions, because there are a lot of people that wound up getting 60s and 70s taking the quiz, but nobody showed up for the questions, right? Ask questions. Been telling y'all that since August, right? Ask questions. That way you know what's going on, right? You got to ask questions if you're confused. Log in, ask questions. If the times I posted for some reason don't work, because I've been putting, at 8:30 and 9:30, mainly because we're supposed to try to stick to this 7-period normal day schedule thing. So this is kind of the end of first and goes into second period. 9:30 is kind of the end of second period and goes into third period. So I can catch everybody. If those times don't work, let me know a time that does work, right? Let me know in Google Classroom, email me, whatever. I'll do a different time. I don't care. I want to make sure we get on, we ask questions, and we understand this material before the test, right? All right, so that's it for today. Again, let me know questions as soon as you can. I'll get to them. That's it.